Okay, so in this section we talk about the ellipse. So an ellipse is like an elongated circle. The idea is we begin with 2 points, 2 fixed points called the foci. Foci is plural for focus. And imagine that these points were nails in a board or something, and you took some thread under each nail and took a pencil in between and sort of sketched around the nails. That would be what creates an ellipse. So the idea is that these fixed points called the foci are the defining points of the ellipse. I mean, they're what you're putting the thread into, and they're what's fixing the thread in place as you take the pencil around. So oftentimes, like when we do problems with ellipses, it'll say something like, here's the equation of an ellipse, just like we would have the equation of a circle or something like that, and it would say find these foci, or perhaps excuse me, here are the foci, these 2 points. Here's the length of the thread, for lack of a better word, though that wording won't be used, but just as an analogy, you find the equation of the ellipse that's been created. So some of the easy basics. So an ellipse is an oval. If we consider it to be centered at the origin, maybe let's say that the foci are plus and minus C0. So I'll label these points here. Okay, so these are our foci at C0 and negative C0. The segment that runs from A1 to A2 is called the major axis. In this case, the major axis is horizontal. It could be vertical too, like we could have an ellipse that's taller than it is wide, something like that. This segment from B1 to B2 is called the minor axis. So understanding the wording there, the major axis is the longer of the two, and it's going to be horizontal or vertical. We're not going to deal with like a slanted ellipse or something like that. Okay. So we could go through and derive the equation of an ellipse based on its definition, but honestly, it's kind of a chore. I usually don't do it as a lecture point. So we'll just say it can be shown that an ellipse that has a horizontal major axis, foci at plus and minus C0, has this equation: x squared over a squared plus y squared over b squared equals 1. It's sort of convenient, even though it's not the wording used in the book, to think of A as the horizontal radius and think of B as the vertical radius, at least in this equation. A is always considered to be the radius of the major axis. If it's underneath x, then it's horizontal. B is considered to be the radius of the minor axis, and so if the ellipse is wider than it is tall, then the vertical axis will be shorter than the horizontal, so the smaller number is under y. The distance from the center to the foci, c, is given here by c squared equals a squared minus b squared. If we had a vertical major axis, then the bigger number a would be underneath y, and the smaller number b would be underneath x. Probably the best way to kind of get used to all this is to look at an example. So in this first equation, it says find the standard equation of the ellipse with vertices plus and minus 5, 0 and foci plus and minus 3, 0, then graph the ellipse. So when we say standard equation, we're talking about that x squared over a squared plus y squared over b squared equals 1. But we can already draw something, excuse me, so we're given that we have vertices at plus and minus 5, 0, and we have foci at plus and minus 3, 0. By using the word vertices to describe plus and minus 5, 0, it's already known to me that the major axis, in other words the longer axis, is going to be horizontal because these points are horizontal with each other. The word vertices means endpoints of the major axis. So we can say already that, like, the equation of this ellipse has a equals 5 because the distance from the center to the either vertex is 5 units, but also we can say c is equal to 3. C is the distance from the center to either focus, plural is foci. And so we see that the distance from the center to either focus is 3 units. But the equation has a b squared. It has an a squared and a b squared. Well, now we can use the fact that c squared is a squared minus b squared to figure out b squared. So this would be 3 squared equals 5 squared minus b squared. In other words, 9 equals 25 minus b squared. And we know that 25 minus 16 is 9. So b squared must be 16. So the equation can be written as x squared over 25 plus y squared over 16 equals 1. Again, I know that the bigger number of 25 and 16, in other words of a squared and b squared, I know that the bigger number goes underneath x squared because the horizontal axis is the major axis. I knew that the horizontal axis was the major axis because the word vertices is used to describe the endpoints. Now the 16 tells us that we go up and down from the center by 4. After all, the square root of 16 is 4. It's just like in a circle when in the equation you see r squared, so the radius is r. This number is telling me the vertical radius by saying the square of the vertical radius. So if I go up and down by 4, I'll be at the end of the ellipse vertically. And now I'll just do my best to sketch an ellipse. Now in the next example, we're given instead the equation of the ellipse, and we're asked to find the vertices and foci. In the last example, the vertices and foci were given to us. And then it says, then draw the graph. Now these are the author's words. I think it's easier to draw the graph first and then find the vertices and foci. But it would be better if this were in the so-called standard form, meaning if the right-hand side were equal to 1. So what I can do here to make 36 into 1 is just divide by 36.
Okay.
9 over 36 reduces to 1 over 4, so I have x squared over 4. 4 over 36 reduces to 1 over 9, so I have y squared over 9, and of course that's 1. So now we can say, okay, so to graph this, we have an ellipse that's centered at the origin. I know that because it's just a plain x squared and y squared. The horizontal radius is the square root of this number, so the horizontal radius is 2. The vertical radius is the square root of this number, so I know that I'm going to go up and down by 3. And so now I'll just graph this ellipse to the best of my ability. Now let's find the vertices and foci. The vertices are the endpoints of the major axis, so they're right here. And so we can see quickly that the vertices are 0, 3, and 0, negative 3. In other words, 0 plus or minus 3. Lastly, we find the foci, and the foci really aren't meant to be an afterthought. They are the defining points. They're where we put the thread in and then stick the pencil into the thread to spin around into an oval. Okay, so the foci are important. Well, one thing we know is that c squared is a squared minus b squared. Again, c represents the distance from the center to either focus. Now, we don't have to get too hung up on the letters a squared and b squared. I mean, the idea is that c squared is the bigger denominator minus the smaller denominator. So I should have c squared equals 9 minus 4. Therefore, c squared is equal to 5. And c is the square root of 5. I could write plus or minus. The only reason I kept it as positive square root of 5 is because c is supposed to be the distance from center to focus. So what this means, square root of 5 is about 2.2. So I would go up a little bit more than 2 and down a little bit more than 2 to sketch the foci. The foci are always going to lie on the major axis, so there's no mystery as to which axis if we know which one is longer. And so we see that the foci are at 0 square root of 5 and 0 negative square root of 5. Okay. So going on to the next example. So we don't have to have an ellipse centered at the origin. I mean, we didn't always have circles centered at the origin. So if we're centered at hk, then we see x minus h and y minus k. And sometimes the equation of an ellipse is completely unorganized, like in example 3. So for this ellipse, we're going to find the center, the vertices, and the foci, and then draw the graph. So, you know, there's some work to do here, just because the equation doesn't look as nice as we wish it did. So to do this, we need to complete the square in x and y. So I'm going to get the x's by each other, get the y's by each other, and bring the 21 over to the right-hand side. Now, one thing that you need to do to complete the square, like completing the square is reliant on having a 1 in front of x squared or y squared or whatever. And we see that we don't have that right now with the x squared. So what I'm going to do here is just sort of selectively factor. Like I'm going to take a 4 out of the x squared and the x term. And we can see it's not like I've cheated here. I mean, if I take 4 out, this still says 4x squared plus 24x. So it's still the same as what I had before. Now we need to create perfect squares so that I see something like these in the equation. Let's remember that to complete the square, we're going to break up these numbers into 2 equal pairs. Like 6 is 3 plus 3, and negative 2 is negative 1 plus negative 1. Then the square becomes completed when we add the product of those numbers. In other words, I'm going to put x squared plus 6x plus 9 here, because 9 is 3 times 3. I'm going to put y squared minus 2y plus 1 here, because negative 1 times negative 1 is 1. Now I have to be a little bit careful here. I would be incorrect if I just put a negative 21 on the right side, because I've added new numbers to the left. We might be tempted to do this because I have a new 9 and a new 1 on the left side. I agree that I have a new 1 on the left side, but I don't agree that I have a new 9. This 9 is in parentheses with a 4 in front of it. So actually on the left side I've put a new 4 times 9. Okay, so now let's factor. X squared plus 6x plus 9 is is x plus 3 squared. After all the numbers that multiply to 9 and add to 6 we've written are 3 and 3. Y squared minus 2y plus 1 is y minus 1 squared. On the right side, if I add these numbers up, I get 16. Lastly, let's put this in standard form by dividing everything by 16. That way we have a 1 on the right side. Four and 16 cancel out, leaving a 4 in the denominator. Nothing cancels in the y's, of course. 16 over 16 is 1. So now we can see that the center of this ellipse is negative 3, 1. Just an easy practical way to think of that. Remember, it's the opposite of the number in here and the opposite of the number in here. So there's our center. The next thing is the vertices and the foci. I think those are easier to find once you graph it personally, so maybe we'll do that next. I mean, that's what we did in example 2. We first graphed the equation, and then we found the vertices and foci. But I really can't graph it without knowing the center, so that's why I went ahead and found that now. Okay. Okay, so we have a center at -3, 1. Well, we have a 4 under the x, telling us that the horizontal radius is the square root of 4, or 2. So I go 2 to the left, 2 to the right. I have a 16 under my y, which tells me that the vertical radius is square root of 16, or 4. So I'll go up and down by 4. And now I'll do my best to draw a nice ellipse. So now that we have the graph, we can talk about vertices and foci. So again, the word vertices specifically means the endpoints of the major axis. We see that the major axis is vertical here because this ellipse is taller than it is wide. So let's see, starting at -3, 1, if we go up to the top here, I see a vertex at -3, 5. And if I go down to the bottom of the ellipse, looks like I'm at -3, -3. And so these are my vertices. Lastly, we look at the foci. And again, we can say now c squared is a squared minus b squared. Again, a squared minus b squared just means take the bigger denominator minus the smaller. So c squared is 16 minus 4. In other words, c squared is 12. And therefore c is the square root of 12. Now personally, to me, this is good enough. Like on an exam, if you use square root of 12, that's fine. You don't have to simplify it, but you know my math lab's going to have you do that. So just in case, we can note that square root of 12 is the same as square root of 4 times square root of 3. And so c is 2 times the square root of 3. So again, the foci always lie on the major axis. So this tells us that we're going to go up and down from the center by 2 square root of 3. 2 square root of 3 is like 3.5. So, you know, go up pretty close to the vertex and down pretty close to this vertex to get our foci. Because, I mean, the vertices are 4 units away from the center. We're going about 3.5. And so we can say then that our foci are -3 and then 1 plus or minus 2 square root of 3. After all, I'm starting at y equals 1 and going up and down by that amount. Okay, so in the last example, we just note really that a circle is a special case of an ellipse. It's where a and b are the same number because the horizontal and vertical radius of a circle is the same. So when this is the case, we just get the classic equation of a circle we saw in chapter 1, x minus h squared plus y minus k squared equals r squared, remembering that hk is the center and r is the radius. So if we have this circle, let's find the center and radius and graph the thing. Again, we're going to get the x's by each other, the y's by each other, and we're going to bring that number over to the right-hand side. We already have a 1x squared and a 1y squared, so completing the square, we're ready to go. The two equal parts of -16 are -8 and -8. The two equal parts of 14 are 7 and 7. And so to get the third number of each, we're going to multiply those. So like -8 times -8 is 64, so that'll be our third number. 7 times 7 is 49, so 49 will be the third number for the y's. We need to remember, too, if we put a new 64 and a new 49 on the left side, we better put those on the right as well. And so now the first 3 factor as x minus 8 squared, while the second 3 factor as y plus 7 squared. The right side numbers add up to 81, so this is the equation of our circle. Remembering that the center is the opposite of the numbers in parentheses, we can say here that the center is 8, negative 7. The radius, let's remember, is the square root of the right side. After all, on the right side you see r squared. So the radius is the square root of 81, in other words 9. So I'm going to graph this circle with center 8, negative 7 and radius 9. So let's go to 8, negative 7. And then I'll go north, south, east, and west by 9 units. Okay, so I went 9 units left and right. And 9 units up and down. And then we'll just do our best to graph a nice circle if we can. This one's kind of a beast, so it's a little bit difficult. I mean, really did a horrible job. Okay, and there's our circle, centered at 8, negative 7, and radius 9. And thus concludes section 9.1.